Hi, everybody. I just want to give you a quick rundown about one of the common learning experiences for Unit 3, which deals with the models of waves. Um, so what we're looking at here is using two programs on the computer, both of which are pretty easy to use. Um, but what the kids are going to be doing is kind of doing some exploratory work on waves, and then they're going to actually use the waves they're kind of exploring, creating to do some graphical representation of those waves using an actual mathematical equation. So the first thing you're going to do is they're going to go to this wave simulator here. Pretty easy and pretty straightforward. I would recommend just off the bat, if you have the time and can let them do it, is just let them play around. It's just kind of a goofy little thing, and they can figure everything out with that. When it comes down to time for them to actually create their wave, what we're going to do is have a set of settings that you want to start with. So first off, we want this to be oscillating, which means that it's going to give a pretty consistent wave. Since we don't the kind of wave energy rebounding here, we don't want an end on that one. And to give us a really true wave that's not going to decrease under the weight of the string, the damping portion here, we come down to none. That's going to give us kind of the true visual of the wave. If they want to go a little bit slower, you can hit slow. If you want it to be normal, you can go normal. It's completely up to the kids. From here, we're really manipulating the amplitude and the frequency. So, if you want really high amplitude, you can do that. If you want the frequency to be really slow, well, that goes down to nothing. But, you can get a really slow frequency. But what you want to do is get the kids to have a fairly regular looking graph. So what they're going to do now is they're going to capture a portion of this. I would tell them to pause and capture a portion of this graph that we're going to be using for the next program. So my personal recommendation is Nimbus Screenshot. I like it. It's a little extension right here. You can also right click, or for the kids in the Chromebook, double tap, and it'll give you the option. What you want to do here is take and screenshot a selected area. So right now we're going to take this, and I'm just going to highlight this stuff right here, which is just kind of the area of my graph. Take that, and I'm going to come here and go save as. It's going to pop up my little window. And I already did one of these waves, so I'm just going to call this one just wave 2, just so we have that information. The kids can name it however they want. 1 and 2 is probably the best thing because you want them to make 2 distinct waves, but that's where you're going to start off with. Then we can come back to here. If you don't want the kids to be coming back to this document necessarily, you can always put both these files or both these links on Google Classroom. And we're going to go to Desmos. Desmos is a program that does kind of virtual graphing. It's really nice because you can put in equations. You can graph a whole bunch of different stuff, so it could be useful for other things as well. It does tie in with Google, so I'm logged in here, which is with my Google account. Kids can do the same thing, so they can save all their work in this. But what we're going to do is we're going to try to have them match the wave they created with the equation that's in here. So we have the image. I have both waves. I'll just grab wave 2 here, and it dumps it in right away. One of the nice things is if it's kind of clunky right off the bat, you can actually get rid of it real quick, and it just disappears. All you have to do is just toggle this button right here, and it'll kind of bounce in and out. Then, really simply, all the kids are going to do is, based off this equation, which is just a basic sine wave equation, they're going to try to figure out how to match this graph exactly. And wow, pretty close. That's pretty good on my first shot. I promise I didn't try this beforehand. And then what they can do is you can actually have them measure the wavelength, the amplitude, the frequency, all of that stuff over the course of the graph. Now, if some of it's getting difficult, you can zoom out in the graph and see a little bit more of the wave. That might be easier for them to do some of the frequency measuring, things like that. Once they have those 3 measurements for frequency, wavelength, and amplitude, what the kids are going to do then is come here to share graph, and they're going to export this as an image. They'll have to download it, which they have a download folder in their Chromebook. It's fine. But they're going to do that with both graphs they create off of the 2 waves they made on the simulator, and add that information for frequency, wavelength, and amplitude into that information as well. So take those, post them, or paste them into a Google Doc, a slideshow. You could have them printed if you want to, whatever it's going to look like that they put out, and then using all that information, they're going to answer two basic questions, which is kind of what the ideas are driving at, is how these relates to energy. So which wave is transmitting more energy, which is directly related to its amplitude, and then which wave is transmitting energy faster, which is directly related to the frequency. And basically, they'll have all the information to look at that. You're probably gonna have to have some pre-teaching that goes into the relationship between energy and amplitude. But as they get that, they should be able to look at those two graphs they have them match, the two waves that they made, and be able to say which wave was doing what based on all the measurements they took. So that is pretty much how you would do that common learning experience. I would recommend definitely playing around with this a little bit before you just kind of ship it off to the kids. But it should be pretty straightforward. So that's it. Hope this helps.